Assalamualaikum. Today our team want to present about the part B for instrument and control project. Okay, first thing first we go to the content. What we have for this project is first current instrument and we use for PLC conveyor sorter. Second, new instrument have a use or new sensor. In our team we use the laser measurement sensor 34ZL and schematic diagram. Advantage and limitation of new sensor, maintenance planning for this conveyor sorter, and the conclusion. Okay, let's we go to the first point of this presentation is current instrument. Let's go for my next teammate, Amir Fatul Mubin.
So hi, I will continue with current instrument. This is some information about our current instrument. Our current instrument device is proximity sensor. Second, detect and locate existence of nearby object without any physical contact or touch. Third, detect change in the electromagnetic field or return. Fourth, this sensor can be used and work for a long time due to its high durability and using only a few mechanical tools. 5. The sensor has high precision because of its very high repeatability. 6. Only detect metallic material or object. It also can detect object in short range, only across range 3 to 30 millimeter. This current instrument also has some disadvantage, which is first, it only can detect metallic material or object, which means it detects only metal object and ferrous object. Second, it can detect object in short range. So if the object in long range, it can't detect. Third, it can be affected by severe factor, which is chemical reaction, temperature, and also water. That's all for me. Thank you.
Thank you, Amir Fatimubin. My name is Arash Idlan, and I'll be continuing this presentation, and I'll be talking about new instrument and sensor. So, we are using an instrument that is a position sensor that has been switched with an optical measurement sensor. The reasoning was due to the sensor having a similar functionality, which is to determine a specification of the object sizes and able to send an input signal to the actuator to sort the object according to its sizes. An optical measurement sensor could detect an object from a distance while providing a visual representation for the object recognition. The detection principle follow the laser scanning method. It proposes a sensor that measures by emitting a light or laser beam that scans the object that made contact with the laser emitted. A product example or model that is used for the circuit would be laser micrometer 3Z4L. Laser micrometer 3Z4L has the capability of determining an object, outer diameter, edge position, pin pitch, and other dimension and specification. That is all for my part, and I'll be giving a chance for someone else to present.
Okay, thank you for my friend Arash Idlan. Now I want to present about schematic diagram. What we get for this schematic diagram is PLC conveyor sorter. And what we get, we get a pneumatic cylinder, uh, laser measurement sensor. We have two measurement sensor, conveyor belt, container, material, have different size of material, small, medium, large, PLC system, emergency stop button, and start stop button. Okay. How this schematic diagram or this PLC converter sorter work? First, we must switch on the converter sorter from start stop button, and conveyor belt move with different size of material. What we get, different size material. First is small, medium, and big. First laser sensor, as we can see, we have two. The first and the second. The first laser sensor is to sense the size of material, and the material is moved forward to the left or to the left with second measurement sensor who have the microsensor to activate the timer of the pneumatic cylinder to work. And the pneumatic will activate from first sensor based on the size of the material and the set of timer based on the size of material. And the material will push out to the container, and the material have a sort from based on the size of material. Okay, just for me, that's all we can see have the work system of this PLC, and our team has decided to change the proximity sensor to the laser measurement sensor. Okay, thank you. We go to the next partner. Thank you. Wait, aku cakap apa?
Okay, thank you for schematic diagram explanation from Daus. Now I want to explain to you about the advantages and the limitation for our new sensor, which is the laser measurement sensor. Okay. The advantages is very many, and that we can conclude that first point is they can be extremely accurate. Second, they are often very light and easy to use. And then the reference is always 100% straight. It is after all a laser beam. You cannot get straighter than a beam of light. Okay, the last point for our advantages for our the laser measurement sensor is they are faster than their analog counterparts. Spaces and substance can be measured nearly instantaneously. Okay, next for the limitation for the laser measurement sensor. There are 3 points, and first thing is they are typically more expensive than analog measuring device simply because of the technology involved. And the bigger is the sensor, it will be more expensive for the laser, for the sensor. Then they are come in limited range and specification. This is because they are hard to manufacture. And then the last thing is they are very delicate because of the susceptibility to physical damage. That's all for me. Thank you. Over.
Next, I'll be explaining about the maintenance planning. These are the steps to achieve the predictive maintenance planning. But before that, I will explain to you about the predictive maintenance. Predictive maintenance is a solution that can aid in determining the state of equipment and predicting when maintenance should be conducted. Because maintenance is only conducted when needed, this approach is to maintenance can ultimately result in cost saving over normal preventive maintenance. There are a few steps that we have conducted. The first step was to determine what we want to predict. The second step is to determine which data we need and assess the quality of this data. The third step is to extract insights from this data. The fourth step is to generate optimized plans and schedules that enables predictive maintenance. And the fifth and final step is to make optimized decisions that ensure predictive maintenance excellence. There are 5 calibrations that were gathered throughout our research and for this circuit and sensor. The first calibration is working curve calibration. The second is the standard addition calibration. The third one is the two-type calibration, which by the name has two types. The first type is the static calibration. The second two type of calibration is dynamic calibration. And the last type of calibration is software for calibration. And throughout, there are 2 procedures for the calibration. The first one is 1-point calibration. The second one is 2-point calibration. That is all for maintenance plan.
Okay, now back to me for the last part in our presentation is conclusion. Let's go for the conclusion part. Okay, we get a 4 point for this conclusion. The first point is this research focus on the replacement of the proximity sensor to the optical measurement sensor. And second, the sample sensor used in the model of the laser micrometer 3Z4L. And number 3 is the scanning method uses laser scanning. And number 4, the advantage outweigh disadvantage. Okay, that's all for me and our team. But I'm for a big sorry for our team. Muhammad Hafiz is cannot be participant in our video because he's have a really um, big problem, and we sorry for their mistake. Thank you.